a shape. We know it's a nice smooth curve. We can now predict what the end behavior looks like. We now know how to find zeros if I give you the first one. And when you're looking at a graph, where do you look for the zeros? The x-axis. So zeros are the same thing as the x-intercept. So we're adding more to it all the time. Now, we have said that if your degree is 4, you can have at most 4 zeros. And we typically, when we're solving, we have gotten 4 zeros. But in terms of looking at a graph, sometimes you don't see 4 x-intercepts. That's because sometimes your zeros might be imaginary. So remember, our imaginary numbers have eyes in them. It's still a 0, but when we're graphing, do we graph imaginary numbers? No, so it doesn't turn out to be an x-intercept. What we need to know about imaginary zeros is what's called the conjugate zeros theorem. And it tells us if you have a polynomial with real coefficients, so if you're looking at a polynomial and it looks like normal, there's no i's in it. If a plus bi is a 0, then a minus bi is also 0. So the imaginary zeros are going to come in pairs. If you have 1, its conjugate is also going to work. And we've said it a few times, but just as a refresher, multiplicity is the number of times we get that 0 back. So a multiplicity of 2 means it came out twice. So if I wanted to find a polynomial that would only have real coefficients in it and met these requirements. So zeros are 3 and 4 plus I. Now if I only use those as zeros, it will have imaginary coefficients. But based on what we wrote down, if 4 plus I is a 0, what else would have to be? So even though I didn't tell you, we know imaginary zeros come in pairs. So if 1 is a 0, its conjugate also has to be, even if I don't state that. So if I'm finding the polynomial, if 3 is a 0, what would be my factor? Okay, if 4 plus I is a 0, we have to do x minus the whole thing. So minus 4 minus I. If 4 minus I is a 0, we subtract off the whole thing. So it would be negative 4 and plus I. So you notice on these, the only difference is the conjugates have opposite signs. You have a plus I and you have a minus I. If you took the time to multiply this whole thing out, then you would get a normal looking polynomial. Those i's would cancel because when you multiply and you get an I squared, what does that turn into? Negative 1. And so when we multiply it would all work out. All right. So let's look at this next one. If negative 2, 5i, and negative 1 minus I are zeros. If 5i is a 0, what else has to be? If negative 1 minus I is a 0, what else has to be? You only change the sign on the I. So just negative 1 plus I. So we would really have 5 zeros here. So if I'm writing a polynomial, I have 5 parentheses. Negative 2, if that's my 0, what goes in my parentheses? If 5i is my 0, that would be x minus 5i. Let's go ahead and do the negative 5i. If negative 5i is a 0, then it would be x plus 5i. So it's just the sign on the I that changes. If negative 1 minus I, so you do x minus those. So if we change those signs, it would be plus 1 plus I. And negative 1 plus I would be x plus 1 minus I. It's just the I that's different. Does it matter what order you write those things in? Not at all. As long as you have them, that's all that matters. And the next example is going to be a little bit longer. I don't think I have enough time to get through it, so I'm going to stop here for today. And we'll pick up with this section tomorrow. Make sure you're getting your Math Excel done if it's not, and come in during advisory if you need help.